Yeah, I feel like doing some binomial expansion today. Just a monster topic for us to tackle as we get back in the groove after our lovely break we just had. And certainly we're not holding back at all today. We're going to, like I said, we're going to see a real bear of a topic today that typically you'll see as a Part 3 question on the Regents exam. But basically, binomial expansion is just like it sounds. We're going to take a very basic binomial here. We've got A represents our first term, B represents the second term, and we're going to raise this expression to a variety of powers today. And I'm going to start with the smallest power possible. I'm going to raise it to the 0 power, which is our favorite one because it doesn't matter whether it's x to the 0 or 2 to the 0 or a binomial to the 0 power. Anything you want to raise to the 0 power obviously turns out to be a 1. So that's our favorite one. Now the second one, let's say if we take the same binomial and wanted to raise it to the first power, anything raised to the first power is simply itself. The parentheses there are purely optional. Now we're going to slowly get a little more challenging. We're going to now square that binomial, and that's just a case of foiling. And you can expand it out, write the a plus b side by side and foil it out, and you hopefully get a squared plus 2ab plus b squared by the time you're done with that. Hopefully I don't need to go into any more depth there. Now the challenging one comes into play when I try to advance to the next power and I try to do a plus b raised to the third power, okay? And we're going to start to be significantly challenged here, I suspect. And in order to really tackle this one, I'm definitely going to expand it myself. I'm going to say, well, that's just a plus b times another quantity a plus b times a third quantity a plus b. That's what raising something to the third power really means. Now, in order to work this one out, what I'm going to do is I'm going to draw my focus right here on the first two binomials, and I'm going to say I'm going to just strictly FOIL those two out, and that would give me the a squared plus 2ab plus b squared that we saw in the previous example. Okay, but we still haven't addressed this third one, so I'm just going to bring that third one down as is. And here's where the fun part happens. What we're going to do is just a whole lot of distributive property. Okay, keep telling yourself just distributive property. We're going to take the a squared and distribute him to both of those terms, and that's going to give me a cubed plus a squared b. Okay, then we're going to jump to this middle term, and I'm going to distribute him twice. And let's see, 2ab times a would give me 2a squared b, and then I would get 2ab squared. Okay, and then last but not least, don't forget about that little b squared. We're going to distribute him once, and then we're going to distribute him a second time, and that's going to give me ab squared plus ab cubed. Okay, and now we're going to just clean that up a little bit. We're going to look for like terms. I'm going to make the claim that these two terms right here are the same. And let's see, I got a coefficient of 1 and a coefficient of 2, so when I add them together I get a 3, a squared b. And then I'm going to make the claim that this term and this term here are also like terms. Add those coefficients together and we'll get 3a b squared. And then that last term is riding solo. So there's my final answer for, we're going to say that the quantity a plus b cubed is equal to this entire expression down here. And you'll notice that was significantly more work than squaring it or, you raising it to the first power and such. And that's what we're going to get ourselves into today is we're going to start, they're going to ask us to do a plus b to the fourth power, or they might get crazy. We're going to go all the way up. They may ask me to do it to the 12th power. And can you imagine writing the quantity a plus b 12 times and having to do that much foiling? Okay, that would probably take up 10 sheets of paper, a couple of hours. It would just really be insane to work that all out. And so what we're going to do is we're going to focus on some shortcuts today. And by the time today's over, we're truly going to be able to take the quantity a plus b, that binomial, raise it to the 12th power, clean it all up, make it look real spiffy and clean, and do so in just a couple of minutes. And so that's what we're going to get into in the next slide, is look at some shortcuts and introduce you to something called the binomial theorem. The binomial theorem is a very special theorem that's going to help us expand these binomials without all the insane foiling and distributing. It looks very, very intimidating at first, but trust me, after we use it a few times, it'll be significantly less intimidating and it's going to become our best friend. But basically, here's what the theorem says. If you want to take a binomial a plus b and raise it to any power in the world, such as the nth power, n's going to represent our general power, here's what you get. Okay, the first term is going to be NC0 times a to the nth power times b to the 0 power. Okay, remember a represents the first term of that binomial and the b represents the second term of that binomial. Okay, plus the second term now is going to be NC1. Okay, that's the C, of course, is just our combinations that we used during our probability chapter. And now A is going to be raised to the n minus 1 power times B raised to the first power plus NC2. Okay, notice that N and that 2 are subscripts. The C is kind of a big rascal. Times A to the n minus 2 power. That's supposed to be a 2. Hopefully you can read it. Times b to the second power plus, and then what I'm going to do is I'm going to use a dot, dot, dot to skip over a bunch of the terms here. And what we'll do is we'll fast forward to the last term. The very last term in that expansion is going to be NCN. A now raised to the 0 power times b to the nth power. Again, what I want to emphasize here, a couple of little things. Within each of these terms, it's purely multiplication. For instance, if we focus on this first term right here, okay, after you calculate NC0, you then multiply by a to the nth power, and then you multiply by b to the 0 power, and so forth and so forth. Then, of course, we got our big plus sign there. And then within this term, it's all multiplication. After you calculate NC1, you multiply by a to the n minus 1 power, and then you multiply by b to the first power, so forth and so forth. So write down this theorem very neatly in your notebook. I wish I could have fit it all in one line and it didn't have to wrap around to that second line, but I think you can make the best of it. A couple other things to point that are worth noting here. When you're all done, if you raise something to the nth power, when you're all done expanding it, you will end up with quote-unquote n plus 1 terms in your polynomial when you're all done expanding. Okay, what that means is if I take a plus b and I raised it to the 6th power, okay, when you're all done with it and it's all cleaned up, you're going to have a grand total of 7 terms when you're all done. Okay, that's very important. The other thing I want to point out is if you look at all the a values, okay, a starts, whoops, got to be in my pen. A starts to the nth power, and then the next term is a to the n minus 1, and the next term is a to the n minus 2, dot, 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 and you finish with a to the 0 power. So what's happening here is that the powers of a are decreasing. Okay, the powers of a are decreasing. Now, vice versa. B starts off with b to the 0, and then b to the first, and then b to the second, dot, 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 and you finish with b to the nth power. So the b's are doing just the opposite. The powers of b are increasing as you expand and develop your binomial theorem. Okay, so without further ado, we're going to jump into our first example. And if you're feeling quite overwhelmed right now, that's perfectly fine. Hopefully after we get 2 or 3 of these under our belt, we'll feel a little better. But our first example says, I want you to take the binomial x plus 2, and I want you to raise it to the 5th power. Okay, so we're going to expand this binomial, and we're going to create a, by the time we're all done, we're going to have a grand total of 6 terms. That's our goal. So, as we get started here, I'm going to shrink my pen down a little bit so I could fit this in, hopefully. Our n value is a 5 because we're raising it to the 5th power. Our a value is an x. Our b value is a positive 2, okay? And then you can look back in your notebook, compare this to the binomial theorem, and we're just going to start expanding it. In fact, a lot of times what I like to do is I kind of like to make these placeholders to represent the terms that I'm going to build. Okay, and I certainly can't fit this all in one line, so I'm going to cheat and I'm going to wrap around here to the second line. There's my 5th term, and then I'm going to finish with my 6th term. I'm going to put a little period there to remind myself that when I get to that 6th term, I'm completely done and I don't have to go any further. Now, the first term is going to be 5c0, and it's going to be my first term raised to the 5th power and my second term raised to the 0 power. Next thing we're going to do, you know what, I think I'm going to just stick with the same color. Let's go 5c1, x raised to the 4th power, and now 2 raised to the 1st power. And we're just going to continue in this pattern, just a whole lot of patterns here today. The third term is going to be 5c2, okay? I've got x raised to the 3rd power, and now I've got 2 raised to the 2nd power. Fourth term is going to be 5c3. We're gradually building. x raised to the second power and 2 raised to the third power. We're almost there. 5c4, x raised to the first power, 2 raised to the fourth power, and finally 5c5, x raised to the 0 power and 2 raised to the fifth power. And now all we got to do is clean it up. Now, a couple of shortcuts that I hope you're picking up on. Maybe you've already seen these. For instance, what is 2 raised to the 0 power? It's really just a 1. So in the future, do I really have to take the time to write 2 to the 0 power knowing that it's just going to be a 1? And my answer to that is no, you really don't have to waste your time writing 2 to the 0, okay? So we could have pretended that we never even wrote that because it's just a 1 and we're going to end up multiplying by 1. Same thing down here. You never really have to write x to the 0 as far as I'm concerned because we know it's just going to have a value of 1. Now as far as the cleanup goes, okay, and this can be a little overwhelming at terms. Let's just take it term by term. First term plus the second term plus the third term plus the fourth term plus the fifth term, and then we'll squeeze in that sixth term if we can. The first term, I have to do 5c0 on my calculator. The calculator says that's 1. So really what we have here is 1 times x to the fifth times 1, which just turns out to be x to the fifth. Next, 5c1. Again, you can do that on your calculator. The calculator spits out a 5. So what we've got here is we've got a 5 times an x to the fourth times a 2 to the first, which is 2. Now you'll notice the 5 times the 2 gives me a 10, and we have the x to the fourth still. Moving right along, 5c2 turns out to be a 10. And again, I'm just typing that into my calculator. Over here, you could agree that 2 squared is a 4. And now I've just got to multiply all these guys together, and I'm going to end up with 40x to the third. Moving right along, 5c3, type it into my calculator, I get a 10. Over here, 2 to the third power is an 8. Multiply all these guys together, and I end up with 80. And of course, don't forget your x squared there. Okay, 5c4, type it into my calculator, get a 5. 2 to the fourth power is 16. 5 times 16 is 80. And again, don't forget your x to the first power. And then last but not least, 5c5 is a 1. 2 to the fifth power is a 32. Multiply those three rascals together and we get just 32. So, in an effort to kind of clean this up and make it look like a real polished, clean answer, I'm going to say that my final answer for this binomial expansion is x to the fifth power plus 10x to the fourth plus 40x cubed plus 80x squared plus 80x plus 32. Okay, and that's my final answer, ladies and gentlemen. At this moment, you are done, and we have to become comfortable with saying that my final answer is a 6-term polynomial. Okay, there's nothing wrong with that. It feels a little awkward saying that this is our final answer, but it truly, truly is, according to what they're asking us to do. Now, that might have felt like a lot of work, but compared to the alternative, okay, foiling that out 5 times would have been significantly harder, longer, and more confusing. And especially once we practice this theorem a little bit, I think you'll agree that it gets significantly easier. Okay, our second problem is going to have a little bit more of a challenge to it. They want me to take the binomial, 3x minus 4, okay, and they're going to ask me to raise this binomial to the 4th power. Okay, so we know when we're all done, we should have a grand total of 5 terms in our answer. So a polynomial of 5 terms. And as I get ready here, we can say that, yes, n is going to be a 4. My a value, the first term, is going to be a 3x. And my b value, here's the bear trap, okay? Here's what I want you to get in the habit of doing. Let's rewrite this as 3x plus a negative 4. Okay, that's the monster bear trap here today. So when I ask you what the b value is, you're going to tell me negative 4, not 4. And we're just going to get ready to go ahead and expand this one out now. We know there's going to be a grand total of 5 terms. I'm probably not going to fit them on one line. Hopefully you can in your notebook, though. So first term plus the second term plus the third term plus the fourth term plus the fifth term. Okay, and we're just going to go ahead, take our time. We're going to set it up real nice and neat. Okay, first term's going to be 4c0. And then our a value raised to the 4th power and our b value raised to the 0 power. Again, in the last slide, I mentioned you did not have to actually write negative 4 to the 0. I'm just doing it for a point of emphasis. Second term, 4c1, 3x to the 3rd power, and negative 4 to the 1st power. At this point, I'd encourage you to hit the pause button and see if you can fill in the next 3 terms, and then come back and see if I have the same thing. So go ahead, hit pause right now, and see if you can fill them in. All right, welcome back here. I'm going to end up, I got 4c2, 3x raised to the 2nd, and negative 4 raised to the 2nd. I got 4c3. That leaves me with 3x to the 1st and negative 4 to the 3rd. And then I finished with 4c4, 3x to the 0. Again, I did not actually have to write that, but I do have to write negative 4 to the 4th. That's not optional. And put a little period there just to remind myself that I am done now. So you'll notice if you look at just the 3x's, they started off with the 4th power here, and then we decreased to the 3rd, to the 2nd, to the 1st, and to the 0. Contrary, just the opposite. If you look at the negative 4, we started with the 0, increased to the 1st, the 2nd, the 3rd, and the 4th, and that should happen. That pattern should happen every single time. Okay, now for the real fun part. We need to start cleaning these rascals up. Okay, what does the first term turn out to be? Well, let's see, first term, second term, third term, fourth term, and the 5th term, we'll see if I'm careful enough to squeeze those in, is we start to evaluate these on our calculator. 4c0 is a 4, of course, negative 4 to the 0 is a 1. Here comes the trick. Not only is x being raised to the 4th, but also the 3 is being raised to the 4th. So that 3 turns into an 81, and then, of course, x to the 4th power. So hopefully you can read that. Now, I need to multiply the 4 times the 81, and that's going to, whoops, I'm sorry, I think I screwed that up. 4c0 is actually supposed to be a 1. Sorry about that. But anyway, we need to multiply the 1 times the 81, and that's going to give us 81 for a coefficient, and then don't forget about your x to the 4th. So there's your first term. Moving on, 4c1, calculator says that's a 4. 3 to the 3rd is a 27. And then x to the 3rd, of course, is x cubed. But don't forget over here, negative 4 to the 1st turns into a negative 4. So here's what we got to do. We got to multiply. Okay, don't be afraid to use your calculator here. We got to multiply the 4 times the 27 and then multiply that by a negative 4. And I ended up with negative 432, and then don't forget about what? Don't forget about your x cubed. All right, 4c2, typed into my calculator. Calculator said 6. 3 squared is a 9, x squared here, and then don't forget here, negative 4 to the 2nd is actually 16, positive 16. So now we're just going to multiply 6 times the 9 times the 16. My calculator said that turned out to be 864, x squared. All right, 2 terms left. 4c3 is a 4. 3 to the 1st is a 3. And then negative 4 raised to the 3rd power turned out to be negative 64. Grab that calculator. Let's multiply 4 times 3 and then multiply by negative 64. I got negative 768 x to the 1st power. All right, last term. 4c4 is a 1. Anything to the 0 power is a 1, and then negative 4 to the 4th is positive 64. So here's what I've got. I've got a 1 times a positive 64. That's what we got. Now I just want to take a moment here and rewrite this one more time. My final answer is 81x to the 4th minus 432 x to the 3rd plus 864 x squared minus 768x plus 64. So there's my final answer, ladies and gentlemen. Those are the 5 terms that I want in my polynomial. And trust me, that is way easier. It might have felt like a lot of work, but it's way easier than the alternative of foiling them out. Again, the most important thing I want you to take away here is the alternating signs that we have created. Notice the first term's positive, the second term's negative, third term's positive, fourth term's negative, fifth term's positive. What we have is alternating signs. And that's going to happen, whoops, helps if I can spell here. We're going to get alternating signs anytime I put a minus sign in between those 2 terms and ask you to raise it to the nth power. So anytime we throw that minus sign in, you instantly know that your final answer is going to possess alternating signs. And just like we said at the beginning, we want to change that to a plus sign and make that a minus every single time. Yeah, tonight's lesson is going to kind of feel like a mini marathon, but the good news is this is our last one. There's my first term, 2x to the fourth minus y. Now the good news is I'm only going to ask you to raise that to the third power. So that's kind of a friendlier one. It shouldn't be as many terms. In fact, because it's being raised to the third power, third power, n equals 3. We know that there's only going to be 4 terms in our final answer. Okay, that's the good news. If we wanted to raise it to the 11th power, then there'd be 12 terms and our workload would be huge. The other thing I want you to notice is because of that minus sign that we see right here, because of that minus sign, we know that we're going to have alternating signs when we're done with this problem. That's something I want you to think about right now. Keep in mind we need to have alternating signs. Your a value is going to be the term 2x to the fourth. Your b value, again, let's go plus, minus. Your b value is going to be a negative y. And I think we're now finally ready to start expanding this one. Let's see, we know there's going to be the first term plus the second term plus the third term plus the fourth term. I'm probably getting a little brave here, but I'm going to try to fit all those in. Shrink my pen size down here a little bit. The first term is going to be 3c0. It's going to be 2x to the fourth quantity to the third power. And then, of course, we have our negative y to the 0 power, but I'm not going to write it. Next term, we have 3c1. The term 2x to the fourth in parentheses being raised to the second power, and then we have our negative y being raised to the first power. Here, I want you to hit that pause button and fill in those last 2 terms and come back and check and see if you got the same thing I did. All right, go ahead, hit pause, fill them in. Okay, welcome back. In the orange are the next 2 terms that you should have on your paper. I had 3c2, 2x to the fourth to the first, times negative y squared. And on that very last term, technically, I had a 2x to the fourth all raised to the 0, but I didn't write it. So anyway, here's what you should have when you got it all set up. Now, what we need to do now is start cleaning these up a little bit. And we do have our work cut out for us. It's not the easiest one in the world. Type in 3c0 in your calculator. You'll get a 1. Now, 2 to the third power is going to be an 8. Ooh, here's an interesting one. How about x to the fourth raised to the third power? We have a power to a power. That's one of our famous exponent rules. We're going to multiply these exponents together and get x to the 12th. So if I multiply everything there, I'm going to end up with 8x to the 12th as my final answer for that first term. All right, second term here. 3c1 is a 3. 2 squared is a 4. X to the fourth squared. We're going to multiply those powers, get x to the 8th. And then I also have a negative y over here on that last piece. So we're going to multiply everything together, and I'm going to end up with negative 12x to the 8th by the time I multiply everybody together. All right, 3c2 is a 3. Let's see, I've got 2 to the first is 2, x to the fourth, and then negative y squared is actually positive y squared when we're all done. Let's multiply everything there together. We end up with positive 6, x to the fourth, y squared. Oh, you know what? Let's go back to that last term. I just forgot. I forgot the y to the first power that I should have had here. I forgot to bring that down. So hopefully you were kind of scratching your head on that last term. I apologize for screwing it up. Anyway, fast forward to our last term, 3c3. Type it in your calculator. That's a 1. And then we're going to multiply by negative y cubed, which is simply negative y cubed here. So there's my final answer. There's the 4-term polynomial that I'm getting. Notice we do have alternating signs. That's what I want you to really focus on. That's really the big key difference on, a lot of times getting these right or wrong on the Regents exam. We've got to focus on getting the correct coefficients. We got to get the correct exponents on each of our terms, the x's and the y's, and again, watch those signs. So I'll tell you what, hopefully it makes a little more sense than it did earlier in the video. If you're feeling uncomfortable, I don't want you to panic too much. We're going to work real hard on these tomorrow. We'll help each other out, and together we'll get through this lesson and really be experts by the time we're all said and done. So good luck, and we'll see you tomorrow.